Okay, the last thing from 3.5 is sort of combining a few of the transformations. Now, I did sort of a loaded question here where it's got 4. I personally would probably only ask you for 2, at the most 3. This is an example of having 4 transformations. So here's the new function. The original function was the x squared function, y equals x squared. Right, but then we did 4 transformations on it. First thing, inside we subtracted 1. Subtracting 1 inside means I've got to move to the right by 1 unit. Right to the right, because I have to overcome that negative, I got to move 1 unit in the positive direction. And then out front, I'm doing 2 things. I've got the multiply by 2. The multiply by 2 is going to stretch it vertically by a factor of 2. The negative 1 reflects it across the x-axis. And then the very last thing is we have the plus 3 outside here all by itself, and so that's a vertical shift. And since it's a positive 3, it shifts it up 3 units. And vertical shifts are always the last thing we do. Again, you follow order of operations. Start the inside shifts and work yourself out. So I always start with the left-right shifts, any compressions and stretches then, and then shifting up and down is the very last thing. All right, so again, we started with that function, we shifted it, and so we're going to go through them in order. So we're going to start with so again, working in order of operations, work inside the function and out. So the first thing we're going to look at is our shift. And so I'm going to draw my original graph so we can kind of compare how it moves. So my original graph is the y equal x squared. The 3 key points that I would use when shifting this would be 0, 0, 1, 1, and negative 1, positive 1. That would be the graph of my original x squared. First thing we're going to do is we're going to take care of the shift the graph 1 unit to the right. So we're going to shift to the right by 1 unit. Which means, so this is where the graph is ending up. And so my original graph was there and it did shift. 0, 0 is probably the easiest one to look at. 0, 0 moved over, right? 0, 0 to here. It moved over to the point 1, 0. 1, 1 was here. It moved over to the point 2, 1. Negative 1, 1 was here. It moved over by 1 to the point 0, 1. All right, so if you look at that, the original, y equals x squared, the original points would have been negative 1, 1, 0, 0, 1, 1. When we shifted to the right units, 1 unit, all right, which was that new function, x minus 1 squared, we did add all of my x values, got added 1 unit, right? This became the point negative, my x values got added, so it became the point 0, 1, right? I add 1 to the negative 1 to get 0. 0, 0 became 1, 0, and 1, 1 became 2, 1, right? All of the x values you add 1 to when it shifts over by 1, right? So we have to add 1 to overcome the negative 1. And those were my new values I had on my new graph. All right, so this is the new graph we're looking at. We're looking at this graph here, and now we're going to do our next transformation. Our next transformation was a vertical stretch by a factor of 2, which means it's going to stretch up and down by a factor of 2, which that means all of the y values get multiplied by 2. Right, and so this is the shape of the graph. So this would be the 2 times that, right? We're stretching it by 2. And so we were at the graph, this was the graph above, x minus 1 squared, and then we're going to shift it by stretching it by 2, so 2 times x minus 1 squared. These were the points 0, 1, 1, 0, and 2, 1. And again, it's a vertical, means the y is being changed by a factor of 2. And so all of my y values get multiplied by 2 when this happens. And so I'm now at 0, 2. Well, 1, 0 is still 1, 0, right? 0 times 2 is still 0. And then 2, 2. And if you go look at the graph, those points are there. There's the point 1, 0. It stayed, right? Because I didn't pull it at all because it was at 0. But then this one moved. That's the point 2, 2, right? That point was at 1, 2. It got pulled up to 2, 2. And the same thing here. This was at 1 or 0, 1. It's now up at 0, 2. Right? It got stretched away from the x-axis. It got pulled up vertically. All right, so that's the second transformation. The third transformation is there, and you could actually combine transformation 2 and 3 by multiplying by -2, and that's fine if you want to do it. But technically, a reflection is a separate transformation, so I'm going to treat it separately. All right, reflect across the x-axis because we multiplied by a -2, a negative in front of the 2. And so I take the graph I just had, this one here, and reflect it across the x-axis. So it means all the y values get multiplied by a -1. Right, so I get a -y. And so my y values were 0, 2, 1, 0, 2, 2. Well, now they become 0, -2, 1, 0 is still 1, 0 because 0 times negative is still 0, and then 2, -2. And if you look at the graph, those are there, right? Here is the 0, -2, right? It was the point 0, 2 reflected. That doesn't go anywhere because it's sitting on my axis, so that's still 1, 0. And then the last one, it was up here at 2, 2, and now it's down here at 2, -2. And there's a reflected across the x-axis. All right, the last transformation is we shift upward by a factor of 3, which means all the y values you add 3 to. All right, so these were the original ones, the ones in my previous step. This is the one we're shifting this green one up by 3, so this is the one we're looking at. And so all of my y values, I should add 3 to it. And so when I do, when I come down here and I write my new point, so it would have been 0, -2 plus 3 puts it at a +1. And then 1, 0 plus 3 is now 3, right? So 1, 3, and then the last one would have been at 2, 1. Sure, that's the new points. And if you look, those are the new points that I have. That one has been shifted up 3 units, right? This goes 1, 2, 3. It puts it there at 0, 1. The vertex gets shifted up 3 units, right? 1, 2, 3 puts it up there at 1, 3. And again, this one gets shifted up 3 units, so it puts it there at 2, not 2, -2, 2, 1. It was at 2, -2. And there's the and there's the final graph, which again, you can, what's nice about the graphing calculators, you can always kind of check your answer. You could plug in each step and kind of check to see that your graph matches up, all right? And again, you have your graphing calculator, it's a tool you're allowed to use. And so you could kind of look through, but this is the behavior. This is what, it's important to kind of understand how numbers affect graphs, right? Because if I wanted to get a specific move, suppose I was building something, but I wanted it to shift over one way or the other, I wanted it to be a little bit taller, I'd have to know how to change my function to do that. Well, if I wanted it to be higher, stretched, I'd have to multiply by the whatever value. If I wanted to shift it over, well, it depends on which way I'm shifting. If I want to shift it to the left, I've got to add something to it. If I want to shift it to the right, I've got to subtract something from it. All right, so it's just important to know how numbers affect my function. How do I manipulate my function to get what I need? All right, I'm going to do one more example of kind of walking you through some different shifts. So this is the one I'm going to look at. I'm going to look at, it's kind of the same setup I'm going to do. So g of x is my absolute value function where I've done some stuff to it. All right, so the first thing, again, you always start inside. So my original function was the absolute value of x, all right, which then I've done 3 things to it. I've got this negative out front, so I'm going to reflect about the x-axis. I'm multiplying inside by a 1/2, so I'm multiplying the 1/2 inside, so it's a horizontal, and it's a horizontal stretch by 2, right? Because I have to, if I wanted to get back to just x, what do I have to do to get the 1/2 x back to x? Well, I'd have to multiply by 2. So I'm going to do a horizontal stretch by multiplying all of my x values by 2, right, to get back to my original function values. And then the last thing is we're going to shift up vertically by a factor of 2. All right, so I've got 3 in this case, and 3 is probably the max I'd ever ask you to do. I did 4 in the last example just because it was an easy one to do 4 with. All right, but always start on the inside. So the inside is the horizontal stretch. That's 1. Then the outside, the negative. And then the very last thing we do is the vertical shift. So I'm actually going to do them in order. So I'm going to start with the horizontal stretch. Horizontal stretch by 2 units. So I'm just going to look at the graph, absolute value 1/2 times x. Remember the original, that's the original, so I'm going to kind of graph it over here. So the 3 key points I'm going to use are basically the same 3 key points I used on the last example, but remember the shape's different. This is a V shape, straight line, straight lines. So 0, 0, 1, 1. And -1, +1. All right, so those are my 3 key points. So there's my original. All right, now I'm going to again do the horizontal stretch, but again, what's happened is I've divided my x by 2, so to get to my original values, I've got to undo that dividing by 2 by multiplying by 2. So all the x values get multiplied by 2. Right, so my original points were -1, 1, 0, 0, and 1, 1. All of my x values are going to be multiplied 2, so now I'm at -2, 1, 0 is still 0, and +2, 1, right? The x values get multiplied by 2. So my new graph, still 0, 0 is where my V is, but now I'm stretched, right? Stretched. Instead of at 1, 1, I stretch out here to 2, 1. Instead of at -1, 1, I stretch it, and I'm now at -2, 1, right? The V has been made flatter. It's been stretched out in the x direction, right? Horizontal stretch, I've pulled it away from the y-axis. I've pulled it out to the x infinity and y infinity, so I've stretched out and made that V shape a little flatter, right? The other one used to come up straighter. Right? And so there's the 1/2 x, right? That's the first transformation. All right, so the second transformation is reflected about the x-axis because there's a negative, so transformation 2 reflected about the x-axis. Y equals negative absolute value of 1/2 x. And so what happens there is it's reflected about the x-axis, and so it means all the y values get multiplied by a negative. So you now get -y. So instead of the point -2, -1, it's going to reflect over here and be -2, -1. Instead of this point 2, 1, it's going to now be down here at 2, -1. 0, 0 actually still stays. So my 3 points are going to be -2, -1, 0, 0, and 2, -1. All right, those are the new points where all of the y values become negative. All right, so it should just give me a reflection down. 0, 0 didn't go anywhere because it doesn't really reflect because it's on the axes. But the -2, -1 moved down here, so now it's -2, -1, and then the +2, -1. And now my V is stretched but flipped over the axes. All right, so there is the -1/2 absolute value of 1/2 x. All right, the last transformation was a shift, and I just have to remember what my shift was. Shift vertically by 2, so I'm going to shift up by 2 units. All right, so the last transformation is we're going to do a vertical shift up by 2. And vertical shift is the last one. We're now going to get the function we want. Negative absolute value of 1/2 x plus 2. And again, we're just going to add 2 to all of my y values, right? Because if I shift this up by 2, well, the 0, 0 is now going to move, and it's going to be at 0, 2. This is going to be up at 2, 1. This is going to be up at -2, 1. Right? I add 2 to all of my y values. And so now I'm going to be at -2, 1, 0, 2, and 2, 1. Those are my new 3 points. All right, So again, 0, 0 does move this time. 0, 2. 2, 1 puts me there. Negative 2, 1 puts me there. And there's my complete and final transformation. There's the graph of the function, which again, you can always type it into your calculator and double check, but it should come out like that, where those are the 3 key points. Again, you always shift things using the 3 key points. So if it's usually something like this where it's a V shape, you always want to have one of your points is where this switches from, increase to decrease, and then a point on each side. Same thing with parabolas. You want to make sure you've got the vertex is one of your key points, and then a number, and then you can pick anything you want on either side of the vertex. All right, so there's an example of combining, transforming, and then it's just taking it step by step, and then you can always, like I said, you can always check your answer on the calculator. Double check that you've shifted it right. This is the shape that if you plug this into the calculator, this is the shape that should come out. Those are the values that should be on your graph. All right, so like I said, basically done there. I am going to do a few more extra just examples if you want to watch the next video. It's up to you. It's not really a part of the lesson. They're just going to throw in, because I think transformations for some students are hard. Actually, it was one of those things that, as a student for me, I found difficult, especially the compressions and the stretches. I actually found those very difficult. And I was taking the class before graphing calculators, so we didn't have them when I learned these, so we didn't get to check our answers. So like I said, I'm going to wrap it up there. It's up to you if you want to watch the extra video or not.